Okay, here's just a quick review of some of the questions on that bonding workshop. It says, or worksheet. It says pick 3 metals and 3 non-metals of the first 20 elements and draw a diagram showing all the electrons. Okay, so maybe I'll pick sodium. Sodium is a metal and it's number 11 in the chart. That means it has 11 protons and 11 electrons. So to draw it, you could do something like this. So I like writing sodium in there, and so it'll have 11 protons, and then it has to have 11 electrons. The first level always has 2. The next level always has should have 8, depending on how many electrons they have. But it usually goes 2, 8, 8, and there's some other numbers after that. Anyway, we're just doing the first 20, so we don't have to worry about the bigger ones. Anyway, sodium 2 and then an 8, and then that's 10, so it needs 1 more electron. So that's what it'd be, a drawing showing all the electrons. And then it says draw each atom with only its valence electrons. So valence electrons, I'd write sodium, and it only has 1 valence electron, so I'd put a dot there to represent its electron. Okay, that's one metal. A non-metal might be something like chlorine. So chlorine on the chart is number 17. So it has 2 and then 8. That's 10, so it needs 7 more. So that's showing all the electrons. To show the valence electrons, you'd write chlorine, and then you want to put 7, because that's the last one. 7 on the outside. So 1, 2, 3, 4, 5, 6, 7. So there's chlorine. For the second question, they ask to draw a Lewis structure, indicate the type of intermolecular forces present, show electrons for LD forces, and then which would have the higher boiling point. I'll just sort of show you this first one that I did as an example. So it's methanol, and if you draw methanol with its electrons, it looks like that. If you draw a structural formula, that's this one, it would look like that. So you just put a dash where there's ever a bonding pair of electrons. Okay, so that indicates a bond. Now to determine whether it has dipole-dipole forces or hydrogen bonding, let me draw it down here. So I've got C, I'll do the Lewis dot diagram. So carbon's got 4. And then hydrogen, each hydrogen has 1. And then oxygen, I'll put right here, and oxygen has 6. So there's 1 there, 2, 3, 4, 5, 6. And then there's another hydrogen right there. Okay, so there's methanol. Now, to figure out which intermolecular forces it has. Let's start with dipole-dipole forces. Dipole-dipole is where one part of the molecule is pulling the electrons harder than the other. And you can look up on your periodic table to see what the electronegativity is. But if you compare electronegativity of oxygen and carbon, they're different. So the electrons would, let me use a different color here, would be pulled more toward the oxygen than they would be the carbon. And what that does is it creates a partially negative charge on that side, because if you have an extra negatively charged electron, that would make it partially negative, and then this side would be partially positive. So if you have a molecule that has partial charges like this, then if you have another molecule, and I'll just draw the structural formula for this one, if you have another molecule that's close, it's going to arrange itself like this so that this partial negative side is attracted to that partially positive side. And this partially negative side is, positive. This partially positive side is attracted to that partially negative side there. And those little dots are called dipole-dipole forces. Okay? Now, hydrogen bonding occurs, and it occurs with this molecule too. Let me just draw it again. Hydrogen bonding occurs when a hydrogen is bonded directly to, I'll put it up here, directly to either an oxygen, hydrogen, a fluorine, or a nitrogen. If you look those three up on the chart, they'd have the highest electronegativity. So if that happens, what happens is this oxygen pulls those electrons so much that this hydrogen sort of is like a positive charge. Now, the oxygen, I didn't draw them here, but it has two lone pairs of electrons. So that one and that one. So if there is another methanol kicking around, like this, then those electrons, they have a negative charge, and hydrogen, since it's being pulled off, has a partial positive charge. Hydrogen bonding is the attraction between this hydrogen and the lone pair of electrons of a neighboring molecule. So that is hydrogen bonding. Okay, hopefully that helps you with those questions.